G'day! I recently replaced a faulty incandescent lamp and a Daiwa SWR and power meter. Replaced that with a number of LEDs. It gives it a nice bright modern look about it. And when I was running that Daiwa meter side by side with this old MFJ tuner, I thought it's probably about time to do the same with this. Now, even though the incandescent lamps still work, there's a fault with it. As you can see, the forward power meter just goes bang against the end stop. Shouldn't be doing that. Another problem this has is that whatever is securing the meter to the front panel is obviously broken. So I thought it was about time to fix this piece of shit up. That's coming up. One good thing about the older ham gear is that it came with a printed manual that you could refer to. So I'm curious to know why the meter goes bang full scale when I apply power to it. Let's just turn that off for now and look at the schematic. It's mostly passive. The only place where the 12 volts is used is to power the meter lamp, we can see here. And it's also used here to drive the forward power meter, which is the meter we're having the problem with. So if we just look at this in isolation, there's our RF detector. We'll have the RF coming from the transmitter into this transformer. RF is coupled into the secondary of the transformer. It's rectified by this diode, which then drives this transistor, which will move the meter. So considering there's no RF applied, there's nothing to rectify, we can rule out the detector part of it. If we ignore the meter lamp for the moment, the only thing left using 12 volts is this transistor here. So what I suspect is we're getting some emitter collector leakage through this transistor, which is why the meter is deflecting when we turn the power on. So I'm going to be concentrating on that transistor to start with. All right, it's time to take the covers off. There are 3 screws on either side, 2 at the top. I've already removed those. We'll have a look inside. I know straight away that I've actually fixed this once before because I've got the 2 resistors here which are non-standard. They're out of the junk bin. And I've remembered that I've previously replaced the 12 volt incandescent that was in here with a 6 volt lamp. And if we take a closer look at this lamp, this is a 6 volt lamp, and from memory, they were the backlight lamps for a lot of the Icom radios from the 90s. I had an IC725 which had these, and I think the 275, 575, 475 may have used them as the LCD backlighting as well. So that's a 6 volt lamp, which explains why I've got those 2 resistors there to drop it down from the 12 volt feed. And it just comes out real easy. You just literally pull it up. Let's just put that to one side. Now that transistor, I'll disconnect the power. That transistor of interest is on this board here. You'll see it in there. So what we need to do is get the board out. I've already removed the 3 nuts that hold the board down. Just pull it out. And it's just as well the meter is loose because, oh yeah, that reminds me. Now, what holds the meter in? It looks like MFJ have made this out of nylon. This is a bracket. It had 4 pieces to the base like that, which is just broken. And I found this in there as well. It's a bit of duct tape, which would have gone over there, and obviously not a good long-term solution. So it's just as well because I can pull the meter out. You need to do that because of the very short wires on the board here. There's Q1, the transistor. It's a 2N3904. That's just a general purpose garden variety NPN transistor. So what I'll do, I'll swap it out with a BC547, a BC549, whatever we have in the drawer here. Just be aware of the pin out of the package. These are both TO92s. They run emitter base collector. The base is in the middle of both of these, but the emitter, with respect to the flat, the emitter and collector have been swapped around. So on the MFJ board, we've got the emitter down here and we've got the collector up there. So to put this BC549 in, we need to reorientate it so that the flat is facing inwards. Sometimes it's easier to remove a device just by heating up all the pads at once. Just put some fresh solder on, and the device just falls out. Now to suck the solder out of the holes. Got to be careful. The wire that MFJ have used is really terrible. It's not very flexible, and if you bend it too much, you're going to fatigue a solder joint. All right, let's put the BC549 in, and like we discussed, the emitter and collector are reversed compared to the 3904 that was in there. So I'm just going to pull the base lead out the other way. So just confirming we've got the emitter going to the bottom. And you'll notice I'm moving the meter with the board because of those stiff wires. Some of these MFJ tuners don't have this transistor fitted. Here's the 941 schematic. The detector is the same, perhaps the meter movements are different. But here the transistor is used as an emitter follower, and that converts the high impedance of the detector to a low impedance to drive the meter. DC gain is unity, but I'm still going to recalibrate the trim pots anyway. All right. Just a bit of IPA to clean up. Can't find my toothbrush, but this will do. Just get the flux off. Alrighty, there we go. Now let's turn it on and see what happens. Just get some power to it. Power on. There you go. You can see the lamp come on, but the meter hasn't gone bang to the end. So that's a pretty easy fix, isn't it? Like I was just saying, this wire is a bastard to deal with, being so stiff. And I've just noticed that this wire is broken off one of the meter terminals there, so I'll have to fix that. So I'll go ahead and do that, and I will remount the board into position, put the 3 nuts back on, and then we'll replace the incandescent lamp with an LED. Now, before I swap out the incandescent lamp for the LED, I'm going to affix the meter to the front panel again. And to do that, I'm using double-sided tape, but this is not just any double-sided tape. This is 3M VHB tape. It stands for very high bond, and it's automotive grade tape. And what I've done here, it's 10 millimeters wide too. So what I've done here, I've got a strip running across the bottom there, and I've got half a strip just running across the top. And this tape sticks like shit to a nappy, trust me. And shall we line it up properly? There it is. Pressure at the top, pressure at the bottom. And that is not going to go anywhere. All right, now we can work on the lamp itself. So I'm going to remove that resistor that I fitted. Resistors. Get rid of those out of the equation. Let's drop the incandescent lamp from the holder. Let gravity do the work. All right, bye-bye. The LEDs LED that I'm going to use, it's the same LED that I used in the Daiwa SWI meter. These are the 3mm white LEDs. They have a 45-degree illumination angle. And what I think I'm going to have to do is actually bend the LED legs so that the LED faces backwards so we don't get a hot spot. So it's basically bouncing light off the back of the meter here. On the LED, I've cut the legs and tinned them. Just remember which leg is which. The anode is generally the small part inside. This is where it gets a bit fiddly. Especially if you don't want to burn yourself. Just got to solder it to those terminals. There's one. Once you get the first one on, it's a little bit easier. And like I was saying, I've angled the LED inwards. And we'll just drop it in. I'm going to fit a 330 ohm 1 watt resistor. Why? Because I just have one in the junk box. And it's about the value we kind of need. Just bear in mind with the single LED here, you're going to have quite a bit of a voltage drop across this resistor. So it needs to be rated appropriately. Okay. Let's put the cover back on just to see what it'll look like without all the light bleeding through the back. And with that 330 ohm resistor, we're drawing 31 milliamps. That looks pretty good. Quite happy with that. And you know, it's just a nice modern look about it. I've fitted some heat shrink to that resistor. Inside, there are two trim pots, R7 and R8. That's for setting the proper meter reading for low and high power, respectively. Here we are on the operating bench, and I've hooked this up. It's in dummy load, bypass mode, and I'm on 10 meters FM, and it's cranked all the way up, so it should be around 100 watts nominal, indicating just under 100 watts. Let's tweak R8. So on the 300 watt range, we get just under 100 indicated. That's about there. You know, this is not scientific. It's not a precision piece of test equipment, so near enough is good enough in this case. Let's wind that down to 25, as indicated on the power meter there. We'll go to the low power range, 30 watts. That's actually, it's reading low, so we'll need to adjust R7 this time. Ooh, a bit touchy. $25. It's going to go back to the 300 watt scale and see how that tracks. So just under 100. I'll set this to 25 on the radio. And what does that indicate there? Mid-20s, that's close enough. Now we can screw the cover back on. That was a pretty easy fix, just one transistor, and while I was at it, I changed the incandescent light for some nice modern new LED lighting looks. Thanks for watching, and you'll see me next time. Cheers.
Boo! Boo! That was the worst thing I ever heard. It was terrible. Horrendous.
Well, it wasn't that bad.
Oh, yeah?
Oh, there were parts of it I liked.
Yeah, I liked a lot of it.
Yeah, it was good.
It was great.
It's wonderful.
Oh, bravo.
More!
Now can I say it?
Yep.
Go away!
Scram!
Get out of here!
Get out of here! Skedaddle! Go away!
Hams Gray!
Well, come on.
All right.